Hi, I'm Paul Roberts. I'm a chemistry teacher here at Andover College, and today I'm going to talk you through how to carry out core practical neutralising an acid. Now, although this is a very straightforward practical, I'm going to give you some hints and tips of how you can get some really good results. So first of all, we're going to take 50 centimetres cubed of 1 molar hydrochloric acid and add it to a beaker. Good idea to use a 250 centimetre cube beaker for this, as you're going to be stirring it and gives the solution room to move. Just with a glass stirring rod, it doesn't have to be glass, but I'm just going to put a dot of the acid on a piece of universal indicator. Wait a few moments and see the colour change. Okay, so that's our initial pH, and looking at my swatch card here, that's a pH of round about 1. So we're going to start the neutralisation, and as I mentioned before, the neutralisation is going to be using calcium hydroxide. Now, for each time you perform the neutralisation, you're going to add 0.3 of a gram of calcium hydroxide. I've measured some out already on the balance here. I took time to tear the balance before weighing it and just add it into the pot. Using the glass rod now to stir, and you'll notice a couple of things happening. It will start off being quite cloudy, and this is because the calcium hydroxide isn't very soluble. It takes time for it to dissolve, but over time it will dissolve, and once all the calcium hydroxide's dissolved into solution and then reacted with the acid, the solution should become colourless again. You might notice a very small amount of fizzing taking place in the beaker, and that's because calcium hydroxide typically has a little bit of calcium carbonate impurities in it, so don't be alarmed if you see a few bubbles appearing. Okay, so now you can see the solution is colourless, and I can again perform another pH check. Noticing that the pH hasn't really changed, it's still around pH 1. You could alternatively, at this point, be using a pH meter. You're going to get more precise results, but still we'd expect still a low pH. And now we're going to continue adding portions of 0.3 grams of calcium hydroxide and stirring. Each time you stir, it will go cloudy, and then as the calcium hydroxide reacts with the acid, the precipitation should disappear and it become colourless. You can always gently tap on the precipitate in the bottom of the beaker and it should clear it up. Continue stirring until there's no more noticeable solid, and once we get to that point, you can then tap and measure the pH. I'm going to continue again. This is my third addition of calcium hydroxide. Each time I'm adding 0.3 of a gram. And once there's no more precipitate, I'll check the pH of the solution, and it still remains fairly acidic. This is my fourth addition. And after the fourth addition, the calcium hydroxide again all reacts with the hydrochloric acid. This means hydrochloric acid is essentially in excess. It's taking longer each time though. Once again, I'm going to check the pH after my fourth addition, and it's still around about pH 1. My fifth addition of calcium hydroxide, and I go through the stirring process. And this time I may notice a slightly more neutral pH. It's all gone into solution, that's a good thing. I'm going to tap it there. No, we still have very much an acidic, very strongly acidic pH. Okay, that's 5 additions. This is my 6th addition. And when this calcium hydroxide is unreacted, or the calcium hydroxide is in excess, there will be a much more alkaline pH. Okay, but stick with it. Keep an eye on the precipitate in the base of the beaker, and give it a stir. See how much has gone after each stir. It may not be the most exciting chemistry, but if you're patient, you can get some very clean results. It's just about all gone into solution now. And let's have a look at the pH. Okay, so the pH is looking slightly more orange there. If you're comparing the initial pH to the pH after 6 additions, we're definitely seeing a closer neutralisation. So the next addition, I'm expecting to see the final neutralisation. Okay, now I'm expecting there to be excess calcium hydroxide this time. As a result, if there's excess calcium hydroxide, no matter how much I stir it, the calcium hydroxide won't react and it will remain as a precipitate. So I'm stirring it, the solution isn't clearing, and this means that all the acid has reacted and now we have excess calcium hydroxide. This isn't dissolving. I'm going to check the pH now and I'm expecting quite a alkali pH. And there we have a pH. This is looking a pH round about 10 to 12. It's not particularly easy to see. In the centre it looks round about 12. So now we can see that neutralisation has taken place and we have excess unreacted calcium hydroxide. I can add another proportion of 0.3 of a gram of calcium hydroxide just to confirm my results. And this time when I add it and stir, I know that the calcium hydroxide won't dissolve and I'm just going to be adding to my excess. I can now check my pH and I'm expecting a similar pH. In fact, it's become ever so slightly more alkaline. So what we have now are a range of coloured pH paper, and we can compare this to our swatch and determine the pH at each addition of calcium hydroxide. A graph can now be plotted of pH versus mass of calcium hydroxide and determine the mass of calcium hydroxide required for neutralisation. To summarise the practical, we've added calcium hydroxide base to hydrochloric acid and we've continued to add it until neutralisation has taken place. This has given us data to enable us to draw a graph of pH versus mass of calcium hydroxide added.